ESE 562. Today we are going to learn about convolution. Convolution is the process of multiplying two signals. So if you have a signal x of t and another signal h of t, the convolution symbol is the star. And it is given by the mathematical equation, the integration from minus infinity to infinity. X of t you replace with x of tau. H of t you replace with h of t minus tau. You integrate with respect to tau. And this is the mathematical equation for convolution. Actually, the purpose of convolution is trying to find the zero input response. If you have an input, x of t, and the impulse response h of t representing the system, the zero state response, y0 state, will be given by the convolution of the input and the impulse response. So if you analyze the equation over here, you notice that the signal h of t is going to be reflected and then shifted before you multiply to x of t and integrate with respect to tau. So the first step that we will talk about today is to reflect and to shift a given signal. We have to learn reflection and shifting a given signal first. So I'm just going to give an example. You have a signal, let's say this is what we call the signal h of t. And it is, for example, the height is 1, it goes from 1 to 2, and this is t. So how do we sketch h of minus t, which is showing the reflection of the signal? So it is just a mirror image. So whatever on the right will go to the left, whatever on the left goes to the right. So you just mirror image the signal, and then the signal becomes this one. As simple as that. So this is h of minus t. Now what happens if you want to shift the signal? Say you are shifting either to the right or to the left. See, the height is still 1. So when you shift the signal, you are adding another constant in the argument. The argument is, what do we mean, as everything inside the bracket. So for example, h of minus t plus 3. So do you shift the signal to the right or to the left? I like to explain this by saying that set the argument, set everything inside the bracket, which is the argument, set the argument equal to the point of change in the original signal, then solve for t. So you see, this is your h of t. Now we want to sketch h of minus t plus 3. So we are going to set the argument. The argument is everything in the bracket. So you have minus t plus 3. Set the argument equal to point of change from the original signal. You see, if you trace the signal and you look at the signal from the leftmost, wow, this is beautiful eye with the long eyelashes. Looking from the leftmost, from the lowest time, and you trace the signal. Okay, then point of change at t is equal to, the first point of change is at t equal to 1, and then it goes up to value of the height of 1, the amplitude of 1, and then at t equal to 2 it goes down. So there's another point of change at t equal to 2. So then let's say you set point of change at t equal to 1. Okay, set the argument, which is everything inside the bracket, equal to point of change in the original signal. So point of change is at t equal to 1. And then solve for t. So now if you solve for t, you will get t is equal to 2. You bring t this side, you bring that one, the other side. So t is equal to 2. So you know that point of 1 will be moved to 2. It will move to point 2. So point 1 will move to point 2. Okay. Then if you set the argument again equal to the next point of change, which is 2, and then you solve for t. T equal to 1. So point 2 will move to 1. So really you're going to have this one, this signal. Because this signal is very symmetric, therefore you cannot see the difference in terms of the shape of the signal. So this is how when you do reflection together with shifting. Always set the argument equal to point of change in the original signal, then solve for t. Okay, let's take another example. Just to talk about point of change and just to talk about reflection and shifting. Another example. Let us see that if you are given this signal. Okay, this is 0, 1. This is 1. So this is h of t. Now, let's add in h of tau. So to sketch h of tau, you are just going to replace all t with tau. And the signal still looks the same, but with tau axis. That's all. It's just a mere replacement or substitution. There's no mathematics here. So this is h of t, this is h of tau. So now you want to sketch h of minus tau. Whatever on the right goes to the left. Whatever on the left goes to the right. So we have like that. Very simple. This is h of minus tau. Then you want to sketch h of minus tau plus t, where t is another constant. So now, what do we do? Set the argument equal to point of change in the original signal. So h of t is the original signal. Point of change is at t equal to 0 and 1. So let us set the argument minus tau plus t equal to the first point of change 0, and then solve for tau. Remember, this time around we are going to solve for tau because t is a variable that shows the shifting. It is not the axis. So we are going to set tau. We are going to solve for tau. So tau is equal to t. So really, you just point 0 is going to be t. So if t is negative, it's going to be here. And then the whole thing follows. You need to follow the reflected signal. So this is t, and this is going to be point minus 1 goes to where? Let's talk about that. See, minus tau plus t equal to 1. Solve for tau. Tau is equal to t minus 1. That's why over here you're going to have t minus 1. That's it. That's all. So that's the height. That's all. For this lesson, we're talking about reflection and we're talking about shifting. And this is important for us to continue with the convolution.